Yeah, I'm really
Yeah. Okay. So welcome to the live session. So first of all, I would like to invite Dr. Chong to have a little bit of talk and a little bit of presentation. Yes, doctor, you are in. Yes.
Okay, so now I want to put my PowerPoint. Can you see now, Hong Xuan, the PowerPoint? Hong Xuan, can you see my PowerPoint I present? How come? Okay. Share. Wait. Now, can you see the PowerPoint? Okay. Now you are presenting to everyone. I want to go full screen now. F5, F5, I want to put my PowerPoint. Can you see now, Hong Xuan, the PowerPoint? F5. Hey, cannot. Hong Xuan? Hey, can you see my PowerPoint I present? Okay, F5. How come? Okay. Okay, Hong Xuan, now can you see full screen? Yeah. Okay. So this is our annual solar eclipse of 21st June, Sunday, 2020. Okay. Okay. You are presenting to everyone. I want to go full screen. Can you see now? That's fine. Okay. Okay, I switch off already. Okay. So now this is from our Society of Penang. Those of you are not familiar, so we are from Penang. So you can see that this is Orion, and this is there you are. You have Polaris. So it shows that we are in Penang, 5 degrees north, and this is not our coconut tree, not durian tree, Penang tree, with the Penang Beach. So we are now broadcasting live from Mr. Lim Choon Kiat Observatory, Pulau Betong, Penang, 5.5 degrees north for our international viewers. Where is it? Those of you who know Malaysia, you have Peninsular Malaysia, you have the mainland on the right, Batu, and there you are the big turtle, Penyu, and there is Lim Choon Kiat Observatory. All right, and it's a southwestern corner. All right, so if you come from by land from Kuala Lumpur, you go by the North South Highway, you come to the Lim Choon Kiat Observatory by the new bridge or by the old bridge, and you come to the southern corner. That's the observatory, and this is how it looks. Very nice. Roll on, roll off observatory. One of the earliest observatories in Malaysia, right? And inside the observatory looks like that. That's Mr. Lim, Hock Eng, Choon Kiat's father, and this is one of the staff from Simeo Reaction. And there you are, the workhorse. I don't know whether Choon Kiat is observing this. This is CK's Celestron 14-inch. Can see well, Hong Xuan, can see, Okay, so now you have now a special eclipse called annular. The case for the annular solar eclipse is the distance from the moon is further away from the earth, so the moon size is smaller. So in this case, you don't have the moon's full shadow, umbra falling on the earth. In that case, you have the total solar eclipse. Instead, you have the penumbra here, falls on the earth, and here you see the ring of fire, the bright sun, and inside most of it covered by the moon, and then you have a bright ring around the edge of the moon. That's called the ring of fire. So this is the case like this. And now is where will it occur? There you are. All right. Now you see on this map, eclipse map. So earlier in the about I would say 1.5 hours ago, it already started 1.5 hours ago. Where in Central African Republic, right? The Atombra were here, and when the Atombra hits the Earth, it's like an ellipse because at that time, this is the Earth is curving away from the sun. It's only when it's in the center here in the Himalayas mountain will be the Atombra be fully circular. Here, the Atombra is fully circular with diameter of 20 kilometers. But over here in Central African Republic, when it touches the Earth in the morning time, the width, not sharp, what I call diameter is 20 centimeter, but the east-west diameter is 85 kilometers. So it's an ellipse. Central African Republic pass to the Republic of Congo. How far does it pass? Now remember, there is this problem of the Earth is rotating. So the Earth is rotating at 1,200 kilometers per hour, and then also the what you call the Earth is also the moon shadow on the Earth is also moving from west to east at as fast as a bullet, 3,600 kilometers per hour. So 3,600 kilometers per hour minus 1,200 kilometers per hour, the actual speed of the Atombra moving from west to east is 2,400 kilometers per hour. And that's what? That's Mach 2, twice the speed of sound. So later on, when you see now on the YouTube, the makan tikus, the moon slowly entering the sun. Actually, the moon is entering the sun at 2,400 kilometers per hour, twice the speed of sound. But why is it so slow? Because you know how far is the moon from the earth? The moon is 400,000 kilometers from the earth. And far away behind the moon, the sun, 150 million kilometers. So they are moving very fast, but because they are very far away from the earth, so they seem to move slowly. So now passing by this Congo, it moves through what they call Ethiopia and Eritrea. All right, crosses the Red Sea into southern. Wait. Yeah, I stop the call. Okay, so it passes through the southern part of the Arabian Peninsula. It goes to a place called Sana'a, capital of Yemen. So this is a place where the annular eclipse will pass over the city with the highest population. For this eclipse, the population of Sana'a is about 4 million, capital of the Republic of Yemen, right? So what is the population of KL? Kuala Lumpur, 1.8 million. So Sana'a population is twice that of KL, and where the annular part of the eclipse will pass over, already passed over. Then you go to the southern part of the Saudi Arabian Peninsula to Oman, all right? Oman, and remember, Oman is lucky because Oman experienced the annular solar eclipse last year in December, and now also annual solar eclipse. So Oman experienced two annual solar eclipse within 6 months, right? And then now it goes to our south of Pakistan to North India, always going at twice the speed of sound, and the maximum eclipse where Arctic, Central African Republic, the shadow of the Atumbra on the Earth surface is an ellipse. All right, ellipse. As you go closer and closer to east, the length of the eclipse shorten, more like a circle, more like a circle. And right here in Uttarakhand, in the Himalayas mountain, at the border of India, Nepal, and China, China means Tibet, you have the Atumbra is fully circular and is about 21 centimeters, 21 kilometers in diameter, and continue to last. All right, you continue to go into Tibet and go into South China, all right, South China, and to this place called Xiamen, Fujian province, all right, and Xiamen's population is about 3.5 million, So, so this is the second largest city where your annual eclipse, and then you cross into Taiwan, Chiayi City. Now remember, it's traveling so fast that the Straits of Taiwan is 200 kilometers in distance, and the shadow will cross the Straits of Taiwan in 5 seconds. 5 seconds into southern Taiwan, into Chiayi City. One of our member, Pei Yong Lip, is there now, all right, to observe the annular solar eclipse in Chiayi City, and after that, bye-bye, you enter to no man's ocean, into the Western Pacific Ocean, and you will end near Guam. So this whole eclipse from Central African Republic to this Guam is about 6 hours, all right? And remember, when the Atumbra hits the Earth and moves, on top of the Atumbra, let's say at maximum eclipse when it was in India, not India, on top here is Arctic Circle in northern Siberia, and on the south is Maldive Island, So actually it's a 7,000 kilometer sphere or penumbra of the moon. And in the center, you have Atumbra of 20 kilometers. So if I that's from north to south, from the northern Siberia to Maldive Island, from east to west, this penumbra stretches from Shanghai in the east to Kuwait. So many people in the world can see the partial solar eclipse. Go to the next picture. So let's come to Penang. So now Penang, you can see that the makan tikus is slightly beginning. Okay, so on my side, the angle is a bit different. On my side, you see that the the shadow is on the right side, all right. But in Choon Kiat pictures on the left side, all right. So because Choon Kiat, when you attach the camera, the position is different from what I view here. So now in the maximum view of Penang, at maximum at 3:52 p.m., still not yet arrived. Maximum, and sorry guys, it's only 14.7 for Penang, right? Because we are, well, remember, we are here, no? We are here. We are here in this part. We are far south of the center line, so we will not have a annular solar eclipse, right? Just for Penang, 14.7% at 3 or around 4 p.m. Kuala Lumpur, Kuala Lumpur is 10.3%, and you see the part covered at maximum is even less. All right, it's about also close to 4 p.m. Johor Bahru, further south, the less the coverage. So Johor Bahru will be 8.3%. Yeah. The further north from Malaysia, the better. And also, and then the further east from Malaysia, let's say you go to Sarawak and Sabah, the further east, then the eclipse will occur later. Because the shadow of the moon always move from the western part of the earth to the eastern part. So it will occur first in Peninsular Malaysia and later on in Kuching, in Sarawak, and later on in Sabah. Okay, so Kota Kinabalu, you see, wow, a lot covered. Kota Kinabalu is about 32.9% covered, but that maximum will occur at 4:23 p.m. Malaysian time. All right, and then the best is of course here, tip of Borneo, 37%. Cabai liao jangan main-main, don't play. So tip of Borneo. But I understand our friends in Sabah will not be there. Instead, they'll be just a bit south of this Kudat. They're observing from there. So I would say maybe they can get about 36%. They're also broadcasting live. All right, Sabah Stargazers Group. And then now if we go to Xiamen in Fujian province will be, wow, maximum will be about local time there, 4:10 p.m. Malaysia is the same, 4:10 p.m. 97.5 covered, 2.5% exposed. So this bright ring here is 2.5%. So this is wonderful, all right? And remember, Xiamen has a population of 3.5 million, double that of Kuala Lumpur. So a lot of people there will be enjoying. So a lot of those amateur astronomers from China will go and crowd down there and observe, all right? So right across the Straits of Taiwan, Chiayi City in southern Taiwan, just north of Tainan, is also good, 97.4%. And then it's a bit later at 4:14 p.m. So this is what is going to occur. All right, this is what we saw. So I think that's about all. I can explain later. So Hong Guan, you want me to continue or any questions? Okay, I continue on this, Hong Guan. What are the things to do during this partial solar eclipse? Of course, first thing is enjoy. Remember, every one of you, either you buy the solar filter or you make it use, right? So some of us already bought our solar filter or kept our solar filter from last year's annual solar eclipse in Johor, Kukup. We kept it and we are observing it with this now. All right. So don't look at the sun with your naked eye. Don't look at the sun through the telescope with naked eye. You need to have a solar filter or a mechanism to filter the light after passing the telescope before going to your eye. Of course, another way is, you see the girl on the right is using the solar filter that is attached to the telescope. She observes the sun with the naked eye, or even better, put the solar filter onto the telescope to observe. Hong Suan, you can hear and see me, yeah? Hong Suan can, Okay. So like this. So that's what we are doing now in Choon Observatory in Balik Pulau. All right. So where are they observing? In Penang Negara in Malaysia, in Heng Yi High School Observatory, they're observing in Penang, in Pusat Kuala Sheikh Tahir in Penang. All right. And they are also observing in Sabah Star Gazers Group, and also other places in Malaysia and all over Asia. All right. So we continue. You can even project the sun's image without any filter on the in front of the telescope. You can project the sun here, and then you have the sun and the moon, and then you can see, right? Provided you make sure that the amount of light has been reduced to fall on the screen, otherwise it will burn the lens of the eyepiece lens of your telescope. Then you can see light, right? You can see. And of course, another one is our pinhole camera. Now that is, the sun is behind this man, the sunlight from the right hand side, is through a small hole here, a pinhole, and this is about, I would say, about 1.5 feet. So by the time it falls into the box here. You see the light here, the pinhole image of the sun, the eclipse image of the sun. So make your own pinhole camera, or even better, we used here before. So some of us, like Yong Lip is in Taiwan now, he did using this mirror. So you have a mirror, small piece of mirror, you cover it with a piece of paper with a hole, and during the eclipse, you reflect the sunlight onto your mirror, and make sure the distance from the mirror to the wall or the screen is about 8 feet or longer, and there you are, the eclipse sun, all right, the crescent sun, all right. So this is the image, the ray image of the crescent sun. Oh, you can catch the image sun on your hand, 8 feet away from the mirror, right? You can catch the crescent sun on your face, on your mouth, on your t-shirt, very nice, with a mirror, all right? This is our reverse pinhole camera principle. You can make two holes, and you reflect two solar crescent. That's what you can do, right? Or you can choose not necessarily a round hole, even a square hole, a triangular hole, any shape of the hole, you will still get a crescent, right? Now, another thing is, you get a slightly bigger mirror, you put on the mirror many holes, say 9 holes, and you reflect about 10 feet away, you will get 9 crescent, or 9 crescent on your face, 9 crescent on your t-shirt. Can be done. Or even better, a bigger hole now, and now you reflect the light 15 feet from the screen, 15 feet away, you will have a bigger solar crescent. So it's easy, very pinhole difficult because a bigger light pinhole, the image of the sun is not so bright. And this is very bright, okay? But make sure that from the mirror to the screen of your t-shirt is at least 10 to 15 feet away. And the other one is you let the sunlight fall on a compact disc, you see the diffraction phenomena, the rainbow. So you can reflect the sunlight here, and you use the mirror and you reflect the sun's crescent on the rainbow like this. You have a rainbow. This is taken in. This was also done in Kukum. You have the rainbow from the CD, and then you have the solar crescent next to the rainbow. Wow! And both are taken at the same time. The light, the solar crescent, the white light, the rainbow is all done at the same time. That's fantastic, right? Now the other one is you can actually cut many holes, about 1.5 centimeter holes in the umbrella, and you find that you can see many suns here. So what happened during the annual phase? Like here you see Hong Guan, there you are on the ground, you see crescent, not clear enough. There you are, you saw that? So you can do that. So our Yonglip got this picture in Taiwan now, right? You can see it, and then if someone were to rotate umbrella, then you see the solar crescent will be dancing on the ground. That's great, right? So we end this presentation for the moment. Hong Guan, I end now. I can continue later. Any question? Yes. Oh yeah. Okay. Okay, come back to me. So you can go back get a picture lah. Huh? Okay. Okay. So your Hong Xuan, since nobody's talking on your side, I can continue to talk. Just only my talking, no need my picture. Okay, okay. Thank you. Okay, thank you. Yeah. I would like to ask CK one question. Hey, CK, why is it the part of the moon cover the sun? Why does it have a kind of orangey look? The red look? Why is it red? That's what I know lah. Yeah, I just want to ask. Yeah. So can I start now? Yeah. So since you are not okay, so I could talk now. Okay, so now you all continue to observe the eclipse. So those people who are in Malaysia, Peninsular Malaysia or Sabah Sarawak, this is your information for you. So Penang maximum obscuration, maximum part is about 3:52 p.m. All right. is 14.7%. All right. I repeat, Penang, 14.7%. Ipoh further south will be less. Ipoh, 13.3%. Kuala Lumpur further south, 10.3%. Malacca further south, 8.7%. Johor Bahru further south, Johor Bahru, 8.3%. All right. Now we go for the east, all right, and north. Kuantan will be 13.1%. Wow, better. Kuala Terengganu, 16.7%. Kota Baru, the best in Peninsular Malaysia, because further the furthest north. Kota Baru will be 18.0%. Then go further east, Kuching. Kuching is 14.0%. Bintulu, wow, because the further north, the further east, the better. So Bintulu in Sarawak is 21.1%. Kota Kinabalu in Sabah will be 32.9%. And then further north, Udat in Sabah, 36.7%. For the east, where our KC Chin is, for the east, Tawau in Sabah, 30.7%. Of course, the best is tip of Borneo, 37.0%. Now we go for the rest of the Asia. Remember, this eclipse can be seen from the whole of Asia, plus Northern Australia and Southeastern Europe. So let's look at the rest of the world. As I said, the first place is Sana in Yemen. Sana in Yemen, it will be annular, and the annular eclipse will last for 4 seconds. The longest part of the annular eclipse will be in Sana in Yemen, 1 minute and 4 seconds. And the obscuration, the percentage sun block is 97.3% for Sana. But now as you go further east, you find that the atom block of the moon on the earth becomes smaller and smaller. So the annular part of the eclipse becomes shorter and shorter all the time. Okay. So now, so if you go to Mecca, Mecca is not total, Mecca will be partial, 70.8%. Medina in Saudi Arabia, 61.2%. There's a place in Pakistan called Dahaki, close to the central part. Only 40 is annular in Pakistan, 40 seconds of annual solar eclipse. Now we go to the point of the greatest eclipse in North India is only 30%, because at that time, the atom blast changed so small, so the annular phase is the center part, the best part is only 38%. So the other part is longer. So New Delhi is the best because New Delhi is 93%. Population of New Delhi is 21 million. Yeah, 21 million. So many people in New Delhi. Then, so many of the people in New Delhi, in India, will tell what the people, those ladies who are pregnant, women, please don't go and see. Stay in the house, hide under your bed. That's what they believe, right? So but all over the world, people are observing can see lah, right? So New Delhi is the most for the partial eclipse. 21 million people can see. And then you have the capital of Tibet in China, Lhasa, 93.6%. Chongqing in Western China, not that, 94.8%, only for partial. And then you come to South China, annual eclipse. There's a small town in China called Leiyang, central South China, annular, 97.8% covered. And the part of the annular eclipse is 53%, increasing now. Hong Kong, partial, 85.7%. So Hong Kong not bad, 85.7%. Shanghai also not bad. Shanghai is 71.0%. Beijing is partial, 48.9%. And now it's annular eclipse, Xiamen in China, 97.5%. And the annular eclipse will last for 58 seconds. All right. Cross the Straits of Taiwan, to Taiwan, Chiayi City, 97.4% covered, and exactly 1 minute of annual solar eclipse. All right. And finally, you will end in Guam, in the West Pacific, 95.4% partial. All right. So that's about all for the moment. Hong Chuan. Hong Chuan, that's about all. Okay. Okay.
Okay, so if anyone have any question, please feel free to type in the question in the comment section, and we will ask on behalf of you to Dr. Chong, so he will be answering your question.
Yeah.
Please feel free to comment.
Okay, so since in between, before the question coming, I can make some comment. Everyone, Choon Kiat also, please look at the sun and the moon now. Do you know that as you look at the size of the moon now, the moon is getting bigger and bigger, bigger and bigger, the moon. Why? Because the perigee of the moon was 15th of June. Today, 21st of June. So 15th of June, the moon was at no, sorry. The moon was at apogee. That means on 15th of June, Monday this week, the moon was further away from the earth. So every moment after Monday, the moon come closer. So now past apogee, the moon actually is getting bigger, bigger. So you observe within these 2 hours, maybe you can measure that the moon diameter is increasing. At the same time, the aphelion means the furthest distance between the Earth to the Sun is 4th of July, not yet occurred. So next month, 4th of July, the Sun is furthest away from the Earth. The Sun will be smaller. So actually now the Sun is getting smaller. The Sun will be smallest on 4th of July, but now we are going closer. I mean, what they call further away from the Sun. So now at this 2 hour eclipse, the Sun's size is actually decreasing and the moon size is actually increasing. All right. And don't forget, today is a double event. No, this morning at 5:50 or 5:43 a.m. in Malaysia is exactly the summer solstice. So what is summer solstice? The sun is at the furthest north in the northern hemisphere. That means today at 5:43 a.m. Malaysian time, the sun is exactly at the Tropic of Cancer. And I checked already at that moment at noon time, the sun cross will be the highest point close to Hawaii. Anyone in Hawaii? So imagine at 5:43, what they call a.m. Malaysian time, that's close to 12 noon in Hawaii. So at that time, if someone is standing in Hawaii at 12 noon, you don't cast a shadow. That is the sun is exactly over the Tropic of Cancer. So after 5:43 a.m., every moment now, the sun is going further south now. Right? So it's further north will be in the summer solstice. So what does it mean summer solstice today? That means that if you are in the northern hemisphere, in America, in Japan, in China, today is the longest daytime time in the northern hemisphere, and the shortest night time in the northern hemisphere. You are in the southern hemisphere, you are in Australia. Today is the shortest daytime in Australia, the longest night time because it's summer solstice. Summer solstice in the northern hemisphere, right? So today is summer solstice. Together we have our and partial solar eclipse. And then another information is we know that any solar or lunar eclipse doesn't come by itself. It's dependent on the earlier and after event. Remember, on the 5th of June, there was a what? Penumbral lunar eclipse, which you can see from Malaysia, right? 5th of June, 15 days earlier, right? We have a penumbral lunar eclipse. 15 days later, today, we have an annular solar eclipse. And in the 5th of July, 15 days from now, we have another penumbral lunar eclipse. But that one, we cannot see from Malaysia. So all these three events are tied down to each other. What is this? 5th of June, penumbral lunar eclipse. 31st of June, annular solar eclipse. 5th of July, penumbral lunar eclipse. All these three are tied to each other. Any question now? I hope I'm Hong Juan. Any question? Yeah. Okay. Yeah. I can answer later. I'm looking at all the other places, Peng Yi lah, Jabal Mufti. Yeah. So, Hong Chuan, I see that in Sabah, they don't have anything because Sabah is cloudy. Yeah. I'm now looking at Apa di Langit in KL. Apa di Langit KL. I'm checking now. So we are lucky in Penang, lucky.
Again, if you have any question, please feel free to ask in the comment section.
Yes. So I see that our Apa di Langit is cloudy in KL. They don't have any eclipse there. KL don't have. I'm looking at Plenty Nagara now. How many people in Chung Cheng Observatory now? Hong Chuan, how many? 20? Must be a lot. Good. You ask them question now. Dr. Chow ask to ask question. Ask. You also can ask. Okay, can. So looks like KL can see, Hong Chuan? Plenty Nagara can see.
Masuk walaupun dah nawan, kemudian progress dia dapat lihat sikit, jadi dia off and on.
Wow, Tung Kiat, your image is very nice. Hong Chuan, you can ask Tung Kiat to move the moon a bit to the right. Move to the right and come down a bit. Because you see the upper part, the top left-hand part of the moon is already disappear. Ask him to bring the moon down and to the right. We can ask our own self. I can answer lah. No problem. Never mind, never mind. I can talk as long I can see the YouTube. I will comment as I see the YouTube. No problem. Okay. So as you all see, yeah, the moon now is on the left. The sun is on the right. The moon now is always crossing the sun's disk at a speed of 2,400 kilometers per hour. That's about twice the speed of sound next to. But because the moon is very far, it seems to move slow. Actually, it's very fast. All right. Of course, this is a question they also ask. Will there be tsunami earthquake around the world? No, because you see, the moon now is actually at what we call close to apogee, very far away from the Earth, and the sun it will be at aphelion, very far away from the Earth in on what we call July the 4th. So the moon and the sun are actually very far away. That's why we're under the eclipse. So the moon gravity and the sun gravity acting on the Earth is less than usual, less than the normal. So there won't be any tsunami and earthquake caused by this annual solar eclipse. So I repeat, where can the people in the world observe this eclipse? You can observe now. Practically the whole of Africa from the northern part to the southern part, southeastern Europe, Romania, Greece, southern Italy, Ukraine, right? And the whole of Asia, right? Whole of Asia, and then including parts of northern Australia, including Darwin in the northern territory, all right? So the whole of China, India, Pakistan, Saudi Arabia, Kazakhstan, can see it, all right? And about now, close to about 4 p.m., everyone, please go out and look at the sun. And please, Lai Hok, can you go outside Chungkia or under the tree where the gap in the leaves, the sunlight fall on the ground? You see a lot of crescents on the ground. Lai Hok, can you hear me, Lai Hok? Please go out of your house and look at the trees, the gap in between the leaves, the shadow of those spots on the ground. You see a lot of crescent on the ground. we are still on the internet, on YouTube. Hong Zuan, I need some comment. Yeah. So if you look at the YouTube from City of City, you find that the moon makan the matahari on the lower left-hand corner looks like from the south. Actually, it's not true. It's because of the way Choon put his CCTV camera. It looks like it's coming from below, from the south. Actually, the moon is now crossing towards the northern part of the sun. If you look at other parts from Malaysia, you see that the moon entering the sun at different locations, not the same. It's all because depends on when they attach their camera system to the telescope, they rotated it, right? But actually, the moon is now crossing the sun in the northern part of the what they call the sun. Why? Because we are south of the annular part. So when you're south of the annular part, the moon will cross the sun in the northern part of the disk of the sun. But you are north of the annular part. Let's say you're close to Siberia or you are in Moscow. In that case, the moon will be crossing the sun in the southern part of the sun. But we are in the below the south of the annular part, so the moon is crossing the sun in the northern what we call part of the sun. Yes, Lai Hong, don't hide. Speak out openly. What's your question? The shadow is not smooth because if you look at it, so what is in the Earth's atmosphere, we have about 100 kilometers of air which is turbulent, right? Imagine we are now in the ISS. If the ISS passes under the eclipse, and I think if the image the eclipse, then the part of the moon, the limb crossing the sun, I think very a lot of noise, a lot of noise, background noise, wrong one. Okay. So because of the turbulence in our Earth atmosphere, that's why you see that it's like twinkling, right? So, so Hong Kong, you are correct, right? That's the delay, there's something about a few minutes delay, very noisy. Remember, 3 3:52 p.m. is the maximum. Not yet, not yet. Another 23 more minutes to maximum in Malaysia. I so I hope at 3:52, are you all going to shout? At 3:52, are you all going to shout and listen? So when you sound in the part, the move is in the northern part of the people. But maximum eclipse must shout what? Hong Kong, this is the view of the eclipse from Chiayi in Taiwan. Can you look? Can you see? There you are. Hong Kong, can you see? Chiayi. This is in Chiayi. It will be annular. Our member Yonglin is there. Chiayi in Taiwan, South Taiwan. It will be annular. Still not yet annular in Chiayi, Taiwan. Very noisy, yeah. Very noisy, very noisy. Any question, Hong Chuan? Very noisy, very noisy, very, very noisy. Very noisy, I don't hear you. Very noisy. You can hear me, I cannot hear you. Any question, Hong Chuan? Very, very noisy, Hong Chuan. Very noisy, Something wrong with your microphone, very noisy. Very, very noisy. Hello? Can you hear?
Yes.
You mute your microphone, Hong Chuan.
Okay.
So Hong Chuan, can I simply comment?
Yes, yes.
Hong Chuan, can I simply comment?
Yes, doctor.
Okay, I'll continue.
Okay.
Now remember, the maximum is about 3 p.m. 52 minutes. Now it's 3:39. Not yet maximum for Malaysia, for Penang. Another 13 more minutes for Penang to be maximum. All right. And remember, the further east you travel from Penang, the later will the maximum occur. So it will occur, the maximum occur later for Kota Baru and Kuantan, and occur even later for Kuching, and even later for Kota Kinabalu, and even later for the tip of Borneo. All right. The further east you go, the later the maximum will occur. The further north you go, the more percentage will be covered. All right. Yes.
Yeah, doctor, you can continue.
Okay, I continue. Yeah. Can we check on YouTube how many people are watching? Hong Chuan, don't know. Okay lah. So for those who want to know more about, okay, never mind, I can continue to talk, no problem. So for the people who want to know more about the eclipse contact, so remember, there are two types of a shadow here. You have the external and internal contact of the penumbra, and then you have the external internal contact of the umbra, right? Because the annual solar eclipse. And also for the external internal contact of the penumbra, you have the contact point of P1 contact point, P2 contact point, P3, P4. And for the external internal contact of the umbra, you have the U1 contact point, U2, U3, and U4. Looks a bit complicated, all right? So one more thing is, whenever you see any solar eclipse, we always look at what is the eclipse magnitude. So straight away, you find from the internet information that the eclipse magnitude for this annular solar eclipse is 0.9940. The eclipse magnitude is always less than 1, cannot be more than 1. So what is the eclipse magnitude? That means at the maximum phase of the annual eclipse, what is the diameter of the moon divided by the diameter of the sun, right? And since it's an annular solar eclipse, so the magnitude should be less than 1 because the diameter of the moon will be smaller than the diameter of the sun. So in this case, eclipse magnitude is 0.9940, all right, 0.99 lah. And because this is a linear measurement in distance, it will not tell you the percentage coverage, Remember, the percentage coverage in the tip of Borneo is 37%. Now, let's say in Xiamen is 97.5% covered. So that is the area. So to get the percentage covered from the eclipse magnitude, you have to square the eclipse magnitude. So the eclipse magnitude here is 0.9940 times 0.5940. You get about 0.9750, 97.5. So you need to square the eclipse magnitude to get the area of the sun covered by the moon. All right. Now another one is, this is series 137, member 36 upon 70. What do you mean by series? What do you mean by member 36 of 7? This is our Saros series. Remember, already the astronomers can predict eclipses very well. All right. So this eclipse of this 21st of June, partial solar eclipse in Malaysia, and annual solar eclipse in other parts of the world is Saros series number 137 and member 36 of 70. What does it mean? Remember, solar lunar eclipse form a Saros series. So this is Saros series number 137. And out in the series 137, there are partial and annular and total solar eclipse. So this is Solar series number 137. This is series, and in this series there are 70 solar eclipses. And out of this 70, today one is 36. The 36th one. Wow, so complicated like this. So when was this discovered? It was discovered about 1000. Remember, the astronomers in the Middle East, ancient Egypt, Babylon, Mesopotamia, Sumeria, Babylon, they are very advanced. So already those astronomers thousands of years ago realized that you can predict eclipses, and later on we call it the Saros series. And mind you, those guys don't have Newton, Newton law of gravity only came in the 17th century. So this was much earlier. So they already could predict eclipses without using the law of gravity. They see a trend, all right? So this is, the today one is 21st June 2020, and partial solar eclipse in Malaysia is Saros series 137, and a member 36 out of 70. So this series of 70 eclipses, when did it begin? Now, ladies and gentlemen, it began in the 13th century. All right, 700 years ago. And the end of the series will be 25th century. So this solar series 127 stretched over a time of 1,200 years. All right, so we are in the middle of it, 36 of the 70th. Right. So if you said, I want to see solar series 137, member number one, number two to number 37, you have to live as long as 1,200 years to see everyone. All right. Covered from the eclipse magnitude, we have to square the eclipse magnitude. So the eclipse magnitude here is 0.9940 times 0.59040. You get about 0.9750, 97.5. So you need to square the eclipse magnitude to get the area of the sun covered by the moon. All right. So another one is, this is series 137. Member 36 upon 17. What do you mean by series? What do you mean by member 36 of 7? This is our Saros series. Remember, astronomers can predict
For all the audience, if you notice, at the right hand bottom of the page, we have a bonus here, which is the Venus. I think for now you can see the Venus in a crescent shape, which is viewed at the same time, which is the same location with solar eclipse, which is at Kiat Observatory here.
Annular solar eclipse from Xiamen. This is the crescent Venus, right? So the bright part, the crescent is the Venus, the clouds of Venus scattering the sunlight back to the Earth. And the dark part of Venus is not the moon. The dark part of Venus is the dark part of Venus, where there's a night time of the Venus. So this is Venus in daytime, simultaneously together with the partial solar eclipse from where? From Pulau Botong, CK's observatory. Very nice, very nice. You can ask CK, Hong Chuan, can we see Mercury now? Mercury, is it safe to look at Mercury? Too close, CK, too close to the sun. Can try, huh? Yeah. Please ask. Ask. Not so clear. Can you come closer and speak? I don't hear you so well. Can ask? Sure. Okay, good. Thank you.
Okay, our participant here is Boomway. Come, Boomway.
Yeah, Boomway, yeah.
Dr.
Wow,
Chong,
Boomway,
hi.
you are always happy there. Okay, good. How are you? Okay, huh?
Dr. Chong, I got a
Sorry, huh?
question to ask about the
Okay,
Venus.
good.
Because
Continue.
normally we see in the downtime, we can see the Venus in the starlight.
Mm.
But now we
Yeah,
just see the Venus is in crescent form. What is that?
yeah. That means, what you call for Venus? Venus is is a inner planet. Remember, Sun, Mercury, Venus, Earth, inner planet. So now, as the Venus goes around the Sun, all right, our Earth also goes around the Sun, big further away from Venus. So as Venus goes around the Sun, there's a part called inferior, I think, conjunction with the Sun, and superior conjunction with the Sun. So inferior conjunction means the Sun, Venus, and Earth. Venus is between the Sun and the Earth. Superior conjunction means Earth, Sun, and Venus. Venus on the other side lah. So basically, right now, the shape of Venus now, the Venus is close to inferior conjunction. So imagine day by day you look at Venus with the telescope, you find that the crescent become finer. That means the Venus will become right in between the Earth and the Sun. So if the Venus become right in between the Earth and the Sun, what happens to the Venus? Venus will disappear, right? So this is it. So, but of course, if Venus is going away, superior conjunction, that means the alignment is like that. The alignment would be Earth, Sun, and Venus. Venus is the opposite side of the Sun. Then in that case, you look at the Sun in the daytime only, Venus will be always a bright round disk, no more crescent. Okay? That means now it's close to inferior conjunction with the Sun. So one more thing, Bunwei, are you listening, Bunwei? Now, you see, Bunwei, it is because of the fact that when you look at the Mars, Saturn, Jupiter, and so on, you see that most of them are full. No, Mars is always round. Jupiter is round. But you look at Galileo saw the Venus. It has this crescent face, and then you have the full face. Oh, he realized that Venus goes in the inner orbit. All right, on the inner orbit, and this shape of the Venus throughout one year of Venus going around the Sun proves that the geocentric model of the solar system proposed by Ptolemy 2,000 years ago is wrong. That what's the geocentric? Earth is the center of the universe lah. What does it mean? If Earth is the center of the universe, means Venus will orbit the Earth, no. So this cannot occur. If you look at the faces of Venus with a telescope, it cannot occur if Venus orbit the Earth. It can only occur if Venus orbit the Sun. So Galileo has the experimental proof that Copernicus principle, the heliocentric model, the Sun is the center of the universe, and all planets go around the Sun, is the correct one. So this proof, observing Venus over one whole Venus year, prove that Venus goes around the Sun, all right, and not around the Earth, and this Copernicus theory is correct.
Okay, thank you, doctor, for the answer. She is
Yeah,
listening to your answer now.
yeah.
Yeah.
Another thing, Bunwei, if you look at the Venus now, how come less than 50% of the Venus is a crescent? How come on the top don't have the crescent? Of course, because of the location of Venus in the orbit. Right now, Venus is close to inferior conjunction. If Venus is in quadrature, what do you mean? What do you mean by if Venus in quadrature? That means you draw the line from the Earth to the Sun to the Venus. If you draw that line from Earth, Sun to Venus, it's like a right angle. In that case, you find that more than 50% of the circumference of the universe is covered by, you can see, right? And if Venus in quadrature, so basically right now, we are already past the maximum. Choon Kiat, 3:52. I have to go out and look at the sun now. Past the maximum already. 3:52, 8 minutes ago. 8 minutes ago. Let's go and have a look. Now I have one question for Moonway and for Hong Chuan. Are you listening? Can you hear? Yeah. If you look at the limb of the moon crossing the sun, where the part where the moon, the borderline between the dark part of the moon and the bright part of the sun, what is that red line that Hong Chuan mentioned is basically the sunlight. Of course, as I said, why is it shaking? Because turbulence in the Earth's atmosphere, right? But I'm saying more. I'm saying that if there's a way you study the light of the sun at the edge of the moon, coming towards the Earth, you study the light, you can actually study what is the atmospheric gases in the Venusian atmosphere. But the light from the sun, leaves the sun, passes through the atmosphere of Venus, comes to the Earth. So some of the information of the atmosphere of Venus is embedded in the light that comes towards the Earth. So if you study the light at the edge of the moon, you no, sorry, I'm not sorry, sorry. This is not the moon. This is Venus. I'm talking about Venus. Sorry. So I made a mistake. I'm talking about the moon now, not Venus. So this doesn't apply for the moon. Doesn't apply. It doesn't apply. Of course, So now Yonglip is in Chiayi in Taiwan. So at the part where the annular eclipse begin and end, if you observe carefully and take a picture class, you can see the Bailey's beach, During the annular solar eclipse, you can capture the Bailey's beach. So if you can capture the Bailey's beach, you can actually map out the mountains and the valleys on the surface of the moon. Yeah, of course. Do we expect the temperature outside the Choon observatory to drop during this partial solar eclipse? Answer is of course not. But this will occur during a annular solar eclipse or a total solar eclipse. So during an annual solar eclipse or annual solar eclipse, most of the sun covered, so the temperature, less sunlight fall on the Earth's surface, so actually the temperature should drop. For example, now in Chiayi, Yonglip is there. So at the maximum part of the eclipse, annular part, the temperature of the surrounding area will drop, right? But here the temperature won't drop because here at maximum eclipse, 85% of the sun is still exposed. So the temperature won't drop. So I made a mistake. I forgot the no, this is a fight. Now, if you ask me, remember, is the shadow, the atombra of the moon falling on the Earth? You see, are you sure that the Earth has got the water, the land, and the atmosphere? No. Above the Earth, you have the ionosphere around the Earth. Many hundreds of kilometers in space. The Earth is covered by a shell of plasma, no? Electrons and protons and ionized particles that create the Van Allen belts and so on. So now you have the moon's atombra falling over the Earth's ionosphere, atombra. Do you think it will affect? I would say yes, because the electrons, protons, and the other ionized particles in the ionosphere, right? If the less sunlight fall on it, it will be affected. They will not be what we call excited so much. More sunlight, more excited. So when the shadow of the moon, atombra, falls onto the Earth's ionosphere, it will be affected, right? So if the Earth's ionosphere is affected, what does it mean? The what we call amplitude modulation, radio transmission will be affected. That means all those radio ham operator, let's say, instead of talking to each other through internet, we talk to each other through the radio wave lah. Yeah, radio transmitter in Malaysia, it transmit and it bounce off the ionosphere and it reaches Japan. And your friend in Japan with the radio receiver can listen to you. So that means during this what you call solar eclipse, maybe the radio transmission through by scattering of the ionosphere can be affected. All right. Okay, so now it's 4:11 p.m. What does it mean? The central spot of the Atombra, which is a 21 kilometer circle, is east of Taiwan, guys. All right. That means the central part of the eclipse, 21 kilometer, the Atombra is east of Taiwan, and very soon it's going to pass over Guam. Right. So when this point pass to let's right now it's just east of Taiwan. Let's say at Taiwan. That means from Taiwan to the west, from Taiwan to the west, another 3,500 kilometers, you can see the partial eclipse. But further west, India, Saudi Arabia, Africa, bye-bye, the eclipse is totally over. All right? The water, the land, and the atmosphere. Above the earth, you have the ionosphere, many hundreds of kilometers right? So when we at this point, that's right now, this, let's say one. That means from Thailand to the west, from Thailand to the west, another 3,000 meters. Africa, bye bye, right? I try to get Heng Yi. I don't see anything from Heng Yi. Live from other places, Malaysia, yes, Heng Yi cannot. It's cloudy in Penang Negara, but clear in Sabah. Hello? Oh, it's okay, it's okay. I thought I'm not on. Okay. Maybe to continue, wait, let me see what to say. Okay, remember the maximum phase in Penang was at 3:52 p.m. just now, right? More than half an hour ago. And now we are going to the end of the last contact, all right? You can see that the area of the sun covered the moon is getting less and less. And this is in the northern part, all right? And now I look at the world map. It's like to the west of very soon, the rest of the Asia covered by the moon's penumbra will wash over to the east, and bye bye, the eclipse will be over. All right, and we wait for the next one. The next one is a penumbral lunar eclipse, 5th of July. 15 days from now. But that penumbral lunar eclipse we cannot see from Malaysia. It's only in the western part of the world can see. Eastern part cannot see. So another 21 minutes before the end of the eclipse for Pulau Penang. All right. That'll be at 4:56. It will be over. Bye bye. So now another 21 minutes for the end of the partial solar eclipse from Penang. And the annular eclipse is practically over because now the annular part of the eclipse is east of Taiwan, is in the Western Pacific. Unless you are on the ship in the Western Pacific, you can see annular solar eclipse. So the annular solar eclipse is all over, from Taiwan, China to India, Saudi Arabia, Central African Republic is over. Only the partial solar eclipse now can be seen. And where can it be seen now? The partial solar eclipse, of course, in East Asia only, China, Southeast Asia, including Malaysia, Northern Australia, Japan. So you can see. Cloudy, yeah, cloudy. Oh, yeah, yeah, yes. Very, very cloudy, yeah. Oh, now clear again. Yeah, yeah, yeah. You can ask Boon Wei to come near the laptop, Hong Chuan. Boon Wei. Ask Boon Wei to come. You ask Boon Wei to come, sorry. Come here, listen to me. Hey, no, Boon Wei, listen, come here. Can you hear me, Boon Wei? Boon Wei, can you hear me? Boon Wei, can you hear me? I don't hear Boon Wei. Boon Wei, are you here? So CJ, the whole eclipse very well recorded. Thank you, very nice. And the weather is good for Penang. No, I can still see. I can see on YouTube. There's a delay for about 2 minutes on YouTube. So it's over already because on my time there is 4:56 already, but I still can see on YouTube. Gone already. Okay, that means gone. Yeah. But the weather in Sabah is still bad. Cannot see anything. Otherwise, Sabah still can see. So here over already over already. YouTube the delay of 2 minutes. Good very good 谢谢你. Yeah, good good. Yeah, sure. So I would say that this is a very successful observation, although most of us are observing online, plus myself also. So thank you to CK, all right, our Chai Hong Chuan, Lim Lai Hock, okay, welcome our Boom Wei, come and help us to handle the equipment lah. Just don't come and stand there. Come to help. We need more people to help, all right. So very successful. So we wait for the next event coming up, all right. Of course. Okay, please end up. Thank you, Hong Xuan. Thank you.
So thank you everyone for attending the live sessions. So now the partial solar eclipse has been ended, and thank you for your